Time is a fundamental aspect of the universe. It governs our lives, influencing every decision we make. We measure its passage meticulously. We use it to organize our days, plan our futures, and reflect on our pasts. Timekeeping, the science of measuring time, is crucial to human civilization. It has evolved from simple sundials to atomic clocks. From ancient civilizations to modern society, keeping time has shaped our world. It has influenced our architecture, our technology, and our daily routines. Accurate timekeeping is essential for many reasons. It allows for coordination in business, travel, and communication. We can schedule events and meetings with precision, ensuring that everyone is on the same page. Navigation relies heavily on precise timekeeping. So does communication, as signals must be synchronized to avoid chaos. Scientific research depends on accurate time measurements. Experiments and observations must be timed perfectly to yield reliable results. Time is the beat to which our universe dances. It is the rhythm that underlies the movements of celestial bodies and the ticking of our clocks. Without timekeeping, our world would be chaotic. We would miss appointments, deadlines, and opportunities. We wouldn't be able to function as a society. Our systems of trade, transportation, and communication would collapse. Timekeeping allows us to understand our place in the cosmos. It helps us track the movements of planets and stars. It gives us a framework to explore the vastness of the universe and the intricacies of our own planet. Through time, we gain perspective and insight into the natural world. In the early days of civilization, humans relied on natural phenomena to tell time. They observed the world around them, using the predictable patterns of nature to guide their daily lives. The sun was their clock, the moon their calendar. These celestial bodies provided a reliable framework for understanding the passage of time. One of the earliest timekeeping devices was the sundial. It was a simple yet ingenious invention that harnessed the power of the sun. Sundials use the sun's position in the sky to indicate the time. As the sun moves, the shadow cast by the sundial's gnomon shifts, marking the hours. A sundial consists of a flat surface and a gnomon. The gnomon is a stick or a triangular blade that stands upright on the dial. The gnomon casts a shadow. This shadow moves as the sun travels across the sky. As the sun moves across the sky, the shadow's position changes. This movement is what marks the passing hours, allowing people to track time throughout the day. This movement marks the passing hours. Sundials were not only practical, but also a testament to human ingenuity and our ability to use natural elements for our benefit. Sundials are simple but effective. They were widely used in ancient times and can still be found in gardens and public spaces today. They were used for centuries by many cultures. Each civilization had its own unique design, reflecting their understanding of astronomy and timekeeping. Another ancient timekeeping device was the water clock. Unlike sundials, water clocks could be used indoors and at night. Water clocks, also known as clepsydras, use the flow of water to measure time. They were an important advancement in timekeeping technology. These devices typically consisted of two containers. Water would flow from one container to another at a steady rate. Water flowed from one container to another. The amount of water that had flowed indicated the time that had passed. The amount of water that flowed indicated the time. This method allowed for more precise timekeeping compared to sundials. Water clocks were more accurate than sundials. They were used in various cultures and were a significant step forward in the history of timekeeping. They could be used indoors and at night. This made them incredibly versatile and useful in different environments. However, they required careful calibration to ensure accuracy. Maintaining the correct flow rate was crucial for the water clock to function properly. The invention of the mechanical clock was a major breakthrough in human history, revolutionizing the way we measure and perceive time. Around the 14th century, these clocks started appearing in Europe, marking a significant advancement in technology and craftsmanship. They used a system of gears and weights to measure time, a method that was both ingenious and complex. Early mechanical clocks were often large and inaccurate, but they represented a crucial step forward in the evolution of timekeeping. They typically only had an hour hand, which was sufficient for the needs of the time. The key to the mechanical clock is the escapement, a mechanism that transformed timekeeping. The escapement is a device that regulates the release of energy from the clock's power source, ensuring consistent movement. This innovation allowed for more precise timekeeping, making clocks more reliable and accurate. It paved the way for the development of smaller, more portable clocks, including the first pocket watches. The escapement works by periodically stopping and releasing the gears, a process that is fundamental to the clock's operation. This creates the ticking sound we associate with mechanical clocks, a sound that has become synonymous with the passage of time. The invention of the escapement was a major step forward in timekeeping technology, enabling more accurate and reliable clocks. It led to the development of more sophisticated clocks and watches, which continue to fascinate and inspire us today. In the 17th century, the pendulum clock was invented. Dutch scientist Christiaan Huygens is credited with this invention. Pendulum clocks offered a significant improvement in accuracy. They were regulated by the swing of a pendulum. A pendulum is a weight suspended from a fixed point. It swings back and forth at a constant rate. The time it takes for a pendulum to complete one swing is determined by its length. Longer pendulums swing more slowly than shorter ones. Pendulum clocks use this principle to regulate timekeeping. By adjusting the length of the pendulum, clockmakers could fine-tune the clock's accuracy. Pendulum clocks became the most accurate timekeeping devices for centuries. They remained the standard for timekeeping until the 20th century. Section 5. Quartz clocks, a new era of precision. The 20th century saw the arrival of quartz clocks. These clocks use the piezoelectric property of quartz crystals. This property means that quartz crystals vibrate at a precise frequency when an electric current is applied. Quartz clocks are much more accurate than mechanical clocks. They are also less expensive to produce. Quartz crystals are highly stable. This stability makes them ideal for timekeeping. The development of quartz clocks revolutionized timekeeping. Quartz clocks quickly became popular. They are now the most common type of clock in the world. Quartz clocks are used in watches, computers, and a wide range of other electronic devices. Section 6. Atomic clocks, the pinnacle of timekeeping. Atomic clocks represent the pinnacle of timekeeping precision. They are the most accurate timekeeping devices ever created. Atomic clocks measure time using the vibrations of atoms. These vibrations are incredibly consistent. This consistency allows for unparalleled accuracy. Atomic clocks work by measuring the frequency of electromagnetic radiation emitted by atoms. Cesium is the most common element used in atomic clocks. When a cesium atom is exposed to microwaves at a specific frequency, it transitions between energy levels. Atomic clocks are incredibly accurate. The most accurate atomic clocks lose less than 1 second every 100 million years. This level of accuracy has revolutionized many fields, including navigation, communication, and scientific research. Section 7. Beyond atomic clocks, optical lattice clocks. While atomic clocks are incredibly precise, scientists are always looking for ways to improve timekeeping technology. Optical lattice clocks are a new type of atomic clock. They have the potential to be even more accurate than current atomic clocks. Optical lattice clocks use lasers to trap and cool atoms. Trapping atoms allows for more precise measurements of their vibrations. This increased precision could lead to clocks that are accurate to within 1 second every few billion years. Optical lattice clocks are still in the experimental phase, but they hold great promise for the future of timekeeping. They could lead to advances in a wide range of fields, including fundamental physics, geodesy, and astronomy. Section 8. Timekeeping and the future. Timekeeping technology has come a long way since the days of sundials and water clocks. From mechanical clocks to atomic clocks, humans have constantly strived to measure time with ever-increasing precision. This quest for accuracy has driven innovation and led to countless technological advancements. As technology continues to advance, we can expect to see even more precise timekeeping devices in the future. These devices will undoubtedly have a profound impact on our understanding of the universe and our place within it. The future of timekeeping is likely to be driven by advancements in quantum mechanics and nanotechnology. These fields hold the potential to revolutionize timekeeping beyond our current imagination. Section 9. Conclusion. Time marches on. The evolution of timekeeping is a testament to human ingenuity. From the simple sundial to the atomic clock, we have always sought to measure and understand the passage of time. Timekeeping technology has played a vital role in shaping our world. It continues to influence our lives in countless ways. As we move forward, we can expect timekeeping technology to become even more precise. These advancements will undoubtedly lead to new discoveries and innovations. The quest to measure time is a journey that will continue to captivate and inspire us.